In this tutorial, we are going to talk about links, nodes, and clouds in computer networking. As well as we are going to discuss packet-switched networks and circuit-switched networks. Network connectivity occurs at many different levels. At the lowest level, a network can consist of two or more computers directly connected by some physical medium, such as a coaxial cable or an optical fiber. We call such a physical medium a link, and we often refer to the computers it connects as nodes. Sometimes a node is a more specialized piece of hardware rather than a computer, but we overlook that distinction for the purposes of this discussion. As illustrated in the figure, physical links are sometimes limited to a pair of nodes. Such a link is said to be point-to-point, while in other cases, more than two nodes may share a single physical link. Such a link is said to be multiple access. Whether a given link supports point-to-point or multiple access connectivity depends on how the node is attached to the link. It is also the case that multiple access links are often limited in size, in terms of both the geographical distance they can cover and the number of nodes they can connect. The exception is a satellite link, which can cover a wide geographic area. If computer networks were limited to situations in which all nodes are directly connected to each other over a common physical medium, then networks would either be very limited in the number of computers they could connect, or the number of wires coming out of the back of each node would quickly become both unmanageable and very expensive. Fortunately, connectivity between two nodes does not necessarily imply a direct physical connection between them. Indirect connectivity may be archived among a set of cooperating nodes. Consider the following two examples of how a collection of computers can be indirectly connected. The figure shows a set of nodes, each of which is attached to one or more point-to-point links. Those nodes that are attached to at least two links run software that forwards data received on one link out on another. If organized in a systematic way, these forwarding nodes form a switched network. There are numerous types of switched networks, of which the two most common are circuit-switched and packet-switched. The former is most notably employed by the telephone system, while the latter is used for the overwhelming majority of computer networks. The important feature of packet-switched networks is that the nodes in such a network send discrete blocks of data to each others. Think of these blocks of data as corresponding to some piece of application data such as a file, a piece of email or an image. We call each block of data either a packet or a message. Packet-switched networks typically use a strategy called store and forward. As the name suggests, each node in a store and forward network first receives a complete packet over some link, stores the packet in its internal memory, and then forwards the complete packet to the next node. In contrast, a circuit-switched network first establishes a dedicated circuit across a sequence of links and then allows the source node to send a stream of bits across this circuit to a destination node. The major reason for using packet switching rather than circuit switching in a computer network is efficiency. The cloud in figure distinguishes between the nodes on the inside that implement the network. They are commonly known as switches and their sole function is to store and forward packets, and the nodes on the outside of the cloud that use the network called as hosts, and they support users and run application programs. Also note that the cloud in figure is one of the most important icons of computer networking. In general, we use a cloud to denote any type of network, whether it is a single point-to-point, a multiple access link, or a switched network. Thank you for watching the video.